Okay, recording has started, and I will now start my presentation. If everybody can stop their videos, then I can start my presentation. Thank you. Okay, I need to share my video now. All right. For the panelists, if you cannot hear me very well or you can't see my video, please let me know. Just talk on the microphone. Let me know. Betty, can you see my video?
Yes.
Okay, thank you. So let me start my presentation. Okay, welcome everyone. Thank you for attending week number 13 webinar of ACCESS.SPACE. Today's webinar will be on satellite applications, and we have three fine panelists presenting their use cases in different countries and places around the world. For the attendees and the people who have registered to this webinar, welcome. Thank you for attending. This webinar is here to support you at home and also the companies which are presenting as well to help them into promoting themselves. And of course, from time to time, we also have topical webinars like we had last week, for example. How do we proceed? We're going to have a 15 to 20 minutes presentation for each presenter, plus myself. That's about, in total, about 1 hour, with about Q&A question after each presentation from yourself, the attendees. If you could actually raise your questions on the Q&A box at the very bottom of your screen. And once we finish the three presenters with the Q&A, we'll have another 15 minutes of wrap-up session of additional questions at the very end. So you'll have a chance also to ask your questions also after the presentations have been done. Everybody's muted for this presentation so that we don't interrupt the speakers. And today's webinar has been sponsored by VideoFlow. So Eran, Shalev will make a presentation on their company. Thank you very much on the sponsorship for today, Eran. So the three panelists today will be Eran Shalev from VideoFlow, Vice President of Products. Vipin Tyagi from India, a former chairman of the board and executive director of CDOT, and Betty Bonnardel, CEO and founder of AV5 Consulting. As I said, this week's week 13, because of the many companies want to do presentation with us, we'll have two webinars today, this week. We'll have the satellite application today, and then tomorrow on key technologies for high power space missions. A very interesting webinar as well tomorrow. So if you would like to register to that webinar, please let me know. And then next week we'll have another topical webinar on propulsion, orbit servicing, and situational awareness as well. And I'm preparing also an ITU panel for the 16th of July. After that, most likely we will take a break, a summer break, and we will begin our webinars likely towards the middle of August. Also, all the webinars which are recorded will be put on YouTube. There's a YouTube channel. I will send out this presentation to everyone, and you will be able to get this link for where you can then watch all the webinars in the past, including the one from today. After today, you can watch all of those. Today's webinar is basically we have 204 individuals from around the world who have registered from 50 different countries. And here's a bar chart of all the registration and attendees of each webinar. So we had been very successful in gathering a lot of interest from around the globe. The type of attendees to these webinars are on this chart. I won't go into details, but basically we have all sorts of professionals in the space sector, in general. All the type of interests are represented, from education to launchers to insurance companies, legal companies, and so on. So I'll leave this to you to read after when I send you the presentation. ACCESS.SPACE Alliance, a little bit on our alliance, has been founded in March 2019 by Betty, myself, and Christian. These are our emails if you'd like to contact us. This is basically an alliance. I will explain in a second what it's about. And also we have a new joiner, also Alice, who's been helping us also to manage some of the data information, and also the YouTube channel which she created. So the ACCESS.SPACE Alliance is here uniting and representing the small satellite sector, in general, even the larger satellite sector as well. We have companies, bigger companies, also manufacturers of large satellites as well in the Alliance. We're here to connect companies, using it as a platform to network and connecting companies together, advising in sharing our experiences, advocating, promoting policies for the benefit of the sector, promoting, educate, and create awareness of the space sector as well, and the opportunities, also helping the research and development side of things. And of course, we're here also to create standards and recommendations and policies for the sector to actually use and promote. We have now 83 members of the Space Alliance, and we have a chart with all the logos here. And also we have partner organization and MOUs, memorandum of understanding. So BIF from India and also Future Aerospace from China are our partners organization where we could collaborate. And also we have an MOU with the European Conference of Postal and Telecommunication Administration. We are an observer, and we can participate to the CPT meetings to promote the sector's interest. Our membership is basically about 1/3 UK, 1/3 European, and the other third is a mix between a larger portion in the United States and the rest of the world. Sorry about that. I'll shut it off. Also, we promote companies in terms of hiring. If companies have opportunities to hire people, let us know. We have a bunch of CVs available for those interested. Contact me if you have available jobs, opportunities, or even for new graduates or internships. For example, let us know, and we'll provide you with contact details of those that have an interest in joining you. So contact myself on that perspective. And now we start the webinar with Vipin. So I'm going to stop sharing my screen. I'm going to have Vipin on board now. Coming on board with your video, Vipin. I'm going to now open up your presentation, and then I'm going to stop sharing my video. So let me just go and get your presentation first, Vipin.
Thank you.
You're welcome. All right. I lost it now. Just a second.
So hi everybody, have a good time of the day, because
all over the world, people who are interested in the telecommunications and who have open mind and looking forward for the new changes have joined all of us here. And you know, what I am attempting to do is actually have a good view of what's happening in India, but more than that is the, you know, what should be done going forward using satellite as the carrier of digital services, and that will provide digital services anywhere, anytime. Next. What's happening in India, as you can see, is that about 1.18 you know, 118 million subscription is already there. So it's pretty big, and it is growing bigger. So as you see in the chart, that the rural tele density is a little lower than, and the urban density is 142.59. What it means is that overall tele density is about 87. And that's why there is a scope for improvement in the rural India. The service providers, I have the chart on the right side, where you see that the service providers are doing pretty well, and there is a 481.59 million mobile number portability. It means the market got consolidated. Also, people changed the provider to provider. Next. What is happening is that in NDCP 2008, that is National Digital Communication Policy, has set out certain objectives here in India. By 2022, they want to give 50 Mbps to everybody, 1 Gbps to every institution, and 10 Gbps by 2022, and 100 Mbps on demand to all development institutions, including the education institution. Also, every household should get at least 50% of the household should get the fixed line broadband. And I'll come to that. What else? So what is happening is then there are some government-funded initiative that you see, which is called Universal Service Obligation Fund. This is a fiber optic based BharatNet. BharatNet means Network for India, which connects 250,000 village panchayat clusters. There are more than 600,000 villages in India, and each one of those should get about 1 Gbps and upgradable to 10 Gbps. Then there is a village net which is being proposed that there'll be about 10 Mbps and upgradable to 100 Mbps. Wi-Fi in a major way is being planned, and there has to be connectivity for everybody. So what is happening is it's fiber, it is Wi-Fi, and it is the rural India which is coming together, because the service providers are not able to address this market because it's not commercially viable for them. Next. And consequently, to bring about what are the technologies for access? The technologies for access are fiber. There is something called GPON, which is now coming to 10 gigabit symmetrical PON, passive optical network for FTTX, is what is already work in progress. About 130,000 villages are already connected with fiber. Also, there is a 2G, 3G, 4G, LTE, which is there, and 5G is under trial. Wi-Fi is being utilized. India has the highest allocation for the Wi-Fi, or the ISM band as they call it. And consequently, you will find that there are 10 million hotspots which are under the planning right now. Now you will see that Wi-Fi is becoming a very, very important technology going forward, because we have seen the power of 802.11 ABGN, and AC is almost there, which is about 3 Gbps, and we are getting into the range of about 10 Gbps with 802.11ax. The copper is almost like vanishing, because landline themselves are becoming lower and lower. And still, after having done all of this, there are 10,000 villages which are still not connected. And these are called aspirational villages that they aspire to be part of the digital community. Consequently, Universal Service Obligation Fund is going to fund the connectivity there using different technologies. And in that process, what we learned is, we have been very much involved in all of these kind of technologies here in India. We realize that there is a space for satellite, and satellite plays a major role, and I'll come to that, and that's the topic today. So Universal Service Obligation Fund will actually take the obligation of connecting all these. Next. Next, please. So satellite evolution is making it possible. What it means is that with the high throughput satellites and with the beamforming, with the all kind of new technologies and compression algorithms and the codecs which are coming in the satellite is now ready to serve the people, providing the digital services. And consequently, what we did is that we gave all the services using satellite as the, and using the Wi-Fi terminal as the front hall or the last access connectivity, and creating the hotspots, covering the entire village, so to say. And we were very surprised that the voice quality that we get out of satellite is fantastic. And I'll come to that. Why? Because the architecture that we have proposed has taken care of some of the things. Next. So innovation to adopt digital technology to satellite. It means that now we always viewed satellite as something which will connect computers or it will connect the satellite phones. I have seen that it works very well in the remotest of the areas where you can have solar connectivity, and you then have the village level infrastructure that you create, which has to be very simple, because you cannot expect to go again and again to the remote place. Consequently, it has to be very, very simple. And that's why the innovative audio and video traffic need to be there. Then the core side, you can have the gateways to PSTN and to the mobile networks. Consequently, you can make a call. If you so desire, you can make a call from there to any place in the world. The content distribution network for the local area has to be right there, close to the distribution point. Then couponing system and lawful interception authentication have to be taken care of. Next. So what all services we have done is the voice calling, both PSTN as well as WhatsApp messaging, Wi-Fi based internet services, all the plain old telephones using copper, because some people are not right there where the satellite terminal is, and you have to distribute it. So you have two ways or two or three ways of distributing it. One is that run the fiber from there, or connect the copper, or connect the create the small hotspot chain there, and all of that we have done, and we ensured that the copper line is also available there. You can call from the smartphone, obviously, without having the GSM coverage, and security and authentication through the OTP can be done. OTP channel becomes a little different than the normal GSM. Local billing and couponing, edge computing for putting the videos there and distributing. Okay. Village level Wi-Fi coverage. Next. So here is the solution that we are talking about. And this will provide almost all the services which are essential, which can be given to a village with Wi-Fi terminal, with a switch which connects all the smartphones, and they have the IPPBX and edge computer. Then satellite receiver will receive this digital data through the modem, and then you have satellite hub where the real heart of the switching and the gateways that is kept there. You have wireless LAN controller to control all these hotspots, and you have network management system for managing the entire thing. Also, the AAA and application servers are all there. You can have voice and the chat server. You can have WhatsApp-like, content, server which will actually connect video, voice. Video, should be enabled only where the bandwidth you get is better. Next. So remote site, there is a VSAT terminal which is required, and service aware switch which is required for connecting the Wi-Fi in a terminal mass. Now Wi-Fi has to be innovated, because if you want to create, you have only one point from there, you want to create the coverage. The usage may be less, but the coverage has to be there to everybody. And consequently, we are able to have the Wi-Fi terminal in the mass mode and point-to-multipoint configuration and also backhauling on the Wi-Fi through multi-radios. And that's how we have connected the entire village coverage. And the cost effectiveness is the key for this kind of an arrangement. Otherwise, this won't fly, because if the villages are far off, then they economically also you cannot expect them to be very far off, very far ahead. That's why the all support of all services is required. Next. Next. Yeah, Tony. Okay, so core side, as I said, you will have all this content. So successful trial has been done. It will be interesting for all of us to know that the village people were so happy to see the system, because when they go to the nearby towns, they find fantastic coverage, but when they come back to their area, there is no coverage, right? So that's why all these voice calling, digital payment, internet browsing, and multitude of services were very, very new and useful to them. Next. So the tremendous potential and workable solution in challenging environment is there, because you can't do it just because it works. There has to be a team of people who are passionate about connecting the unconnected. And then local government support sometimes is important, because you have to go there, you have to find a place like a school. Schools have played a major role because they were interested in education to be given there, and the teachers were very excited to see this connectivity there. Involvement of the community, you can't expect the people who are highly skilled to go there and actually start working there every day. So O&M has to be so simple on their own mobile phones, where they do everything. Training and maintenance and telecom infrastructure has to be taken, including the theft. So I think you have to keep sometimes the lock and key and all of that. There's also sometimes politics, local politics, which is there. Next. So that's why it is important. Next, please. It's important for us to see that the multiple satellites and all work. We have used the ISRO is the Indian Space Research Organization. They have multiple satellites. In fact, this is one of the most successful space program. They have launched 104 satellites in one launch and created world record. Now there are so many satellites which are there. They have GSAT-14, which we have used. We have used GSAT-11. We have used the THICOM 8. And before that, Eutelsat for multicast video using Wi-Fi to enable another business model. These are all were used. These satellites were used in the project. Yeah, next. There is a district which is there in northern part of in Himalayas, and and that's where you can see on the left hand side that we actually connected it in a place called Haristal village panchayat, and just a small antenna, and then the Wi-Fi hotspot is what all it required through, and we needed solar panel. And people were so happy. You see the Taliseti village panchayat, again, a remote place where there is no road. Next. So another thing is the Tripura, which is northeastern part of the country, where there is a lot of rain, and sometimes also people don't go there very often. So that's why you can very clearly see on the right hand side, there is a solar panel which is installed, there is a school, and then there is another panchayat. Panchayat is a cluster of villages, which is called Gokulpur, and that's where we installed all of this, and the whole thing worked. Next. So as you see on the right hand side picture, there is a solar panel, there is a terminal for connecting satellite, and then you see there is a Wi-Fi hotspotting, then point-to-point antenna which connects nearby. also the copper that connects the cable in nearby buildings. All of this is the system. One thing I want to underscore is that the cost is the differential. And cost effectiveness and ease of operation is what is provided. You can configure the entire system in one place, being satellite, and then you can take it and put where the beam is. And this will end the isolation of these places from the digital economy, because you know, we have experience in India, almost all payments in the remote places are being done now. Billions and billions transactions are done on the payments are done on digital media. Also, societal involvement, because couponing is required. So you need to have somebody who can give coupon, collect money. All of that will have a local guy whom you can train, right? And this enormous digital divide that exists, about 4 billion people, unconnected human worldwide. The case study may be from India, but it is equally applicable everywhere. And as we go along, it will come. So that's all from my side. I want to thank Tony for being such a wonderful support, and thank everybody.
Okay, thank you, Vipin. I'm going to now ask you 1 or 2 questions from our participants, and then the remainder of the questions we will ask later on the main section. Let's go with Rajesh, who's asking the question: how can your multi-band satellite ground terminal be utilized for distance education?
Yeah, very good question. In fact, the education is a sector where the digital connectivity is required. And with the high throughput satellites coming along, the larger constellations coming along, the education becomes one of the very, very important factor for us to put it there, because 2 Mbps connectivity is good enough for us to have the classroom video already stored from a remote CDN, and then you can run the classes there. So I would say that this could be a very powerful tool for us to spread the awareness, spread education, educate people on digital economy, bring them along.
Okay, thank you. I think we're going to stop here for the questions. We'll ask the remainder of the questions afterwards. So can you stop your video, please, Vipin? No, I'd like to get Eran on the screen. Go ahead. It's all yours now, Eran.
Thank you, Tony, and thank you, Vipin, for a very good presentation. Okay, so I would like to speak today about the combination of IP networks and satellite to create a hybrid satellite IP network for increasing the operational efficiency of broadcast over satellite. A little bit about who we are. We founded in 2010. We are an ex-Scopus Video Networks veterans, meaning that I have lots of experience in developing broadcast equipment, specifically IRDs, encoders, multiplexers, etc. We are now focusing mainly on the fusion of the broadcast requirement and the IT requirements together, so that we will able to allow professional broadcast over any IP network, including over unmanaged networks like the internet. We are major technology contributors to groups like VSF and RIST, which are working together to create an industry standard to ensure interoperability between vendors for professional video broadcasts over IP. We have 5 patents in this area of service continuity and video quality protection. And what we really want to provide is products that increase the operational efficiency, specifically when talking about IP networks. The specific topic for today would be hybrid SAT IP. And let me start by saying that video is more sensitive than any other traffic type to network impairments. Data integrity is very important. Missing data automatically incarnates itself into this little pixel that you see here, in the picture. Delay variation, also called sometimes as packet jitter or data jitter, is also very important because the receiver or decoder should be in sync with the encoder or source. In the case the sync is lost, there is simply no video. In addition, bitrate fluctuations is also a major factor because video has to have a constant bitrate, and if not handled, accurately, if you're trying to push more bitrate into a pipe than it could actually tolerate, then lots of data is going to be lost, and the result again is disturbing video, or even to the fact that there would be completely no video at all. So video flow is in IBC since 2012, and I think that since 2013, IBC of 2013, we're getting some operators coming to say, look, we see problems with satellite. The main trigger for the hybrid SAT actually comes with 5G, where in some countries, like in the United States, 5G is actually going to overlap with the C-band frequencies. But as Dr. Chaim Mazar, who is the vice chairman of ITOR Study Group 5, said to me, it's more than just 5G, okay? It's actually any kind of interference that you can find. It could be electromagnetic interference. It could be because of 5G. It could be severe weather conditions, which we see more and more of it, unfortunately, because of the global warming and sun flares. All these can, degrade the quality of service that is provided by satellite to its receivers. And it's not only C-band, actually. It's all across the board. It can be C-band, it can be KU, and definitely KA, where KA is the most susceptible one for weather conditions than any other frequency band. What we identified are two possible interferences to the service. The first one that actually causes the link to be up and running, which is great, but data integrity is jeopardized. The second one is that the level of interference is so high that, that in fact there is no satellite link available. So the obvious solution is, let's go with another satellite link, right? But that could be a very expensive solution sometimes, and that might prevent actually from giving the appropriate service level to the customers. The solution we propose is, let's add an IP network in parallel to the satellite network. There is a complete ecosystem or network that we had compiled based on our products. In this specific presentation, I'm going to focus only on the satellite transmission aspect of things. Before moving into how the system looks like, or how the ecosystem look like, if you think a little bit about this, I'm asking you to do something that is, from firsthand, sounds a little bit irrational or illogical. What I'm asking you is to use a unreliable network to increase the reliability of a satellite, which is obviously one of the most reliable transmission means available today. So this pyramid actually shows some of the developments and technologies that we developed here in VideoFlow together with other vendors that are available to the market. And the idea being is to match the IP network to the broadcast requirements. At the end of the day, the proof is in the pudding, right? So here's an example. This is actually a screenshot from a Plugfest that we had with a vendor called Cobalt. We are in Israel. Cobalt is in the United States. And watch this. We got bursts of over 86% of data lost. Okay. On the other hand, as you can see here in this oval, we never lost a single packet. So 86% packet lost, all of them were recovered, all packets received. And this is why we're saying that we can take actually an unreliable network like IP and even a standard consumer grade internet connection and aid satellite reliability. When we're talking about increasing operational efficiency, we identified three parts or three sections into this ecosystem. The first one is obviously monitoring. The second one is what happens when there are interferences to the satellite link? How do we increase the reliability of the service? And the third one is what happens if the link is completely down or is considered to be down because the level of data that is there is literally not working. So monitoring, reliability, and backup. Let's start with monitoring. The reason I'm starting with monitoring is not because it is satellite related. It is more it's more related to operational efficiency. But in fact, what it says is, let's take some kind of an IP network and let's put some instances, at the MCR in each one of the receivers. This is an example of using satellite distribution to television antennas, DVB-T or DVB-T2, okay? And then let's take the video or the stream that the IRD is receiving, okay? Demux it or transcode it, depends on what we have here, and let's send it back to the MCR. So instead of having some kind of statistics or or some kind of alarms that the IRD is producing, you can actually see now the stream in the MCR. That is a big change, compared to red, orange, yellow, green kind of thing. Okay. Not only that, we unfortunately in a COVID-19 situation, and what we wanted to make sure is that we can allow collaboration. And for that, you can actually see each one of the streams received here. If you have sufficient uplink speed, you can see it here on your mobile or laptop, okay? So that experts can collaborate with the team that is in the MCR, as well as with anyone in the receiver side. Furthermore, the idea being is that all the good statistics that we can provide for the operation can every aspect of them can be accessed remotely. So once again, no need to send send somebody out there in case there is a problem. Most problems, unless there is a physical problem, most problems can be managed, isolated, and fixed remotely. So, what is the idea behind increasing the reliability of a satellite? So the idea being is, if I lost 10% in the satellite link, I want to be able to compensate 10%, the same 10% that were lost here. I want to compensate it via the IP network, which means in essence that the data integrity as well as timing is maintained at the feed to the exciter modulator of this antenna in this example. There are two possibilities to do so. The first one is intrusive. This is a solution that in some cases available today. The main problem is that in order to be able to identify which data is lost, you have to synchronize the satellite network into the IP network. So you can actually mark which part is missing and then recover it via the IP network. The main problem is that the only way to do it today is to use an MPE service, which basically says, let's take a DVB satellite for television, broadcast, and let's actually convert it into a one-way IP network. So if it is a one-way IP network, we can treat the satellite link as an extension of the IP network. It works, but it's very expensive and it's not ubiquitous, okay? There should be another way. And this is where video flow is coming into the game. We had invented a non-intrusive solution for this. In this non-intrusive solution, we can actually analyze what we get here, and based on some watermarks or some markers that are embedded in the stream that was sent via the satellite, we can tell the video flow on the transmitter side, which portion of data is lost, and then ask it to resend the data and then complete the integrity of the data and the timing before applying it to the television antenna. So what are the benefits of the non-intrusive out-of-band packet recovery? First of all, it can overcome adjacent and co-interferences. At the end of the day, it's not a bandpass filter, right? We don't have to do some tuning. We don't need to make sure to analyze which kind of interferences we see. We don't really need to understand the nature of each one. What we know is that there is either a data received or not. And based on that information, we can recover the data lost by asking the transmitter to retransmit it, okay? As I said before, it would require some tagging for both the satellite and the terrestrial IP network, which means that, you know, if you have enough link budget, let's say to put it on 10 to the minus 7, okay, the same link budget, you know, can actually tolerate now 10 to the minus 1. And I think that we can do even higher packet error rate than 10%. As I showed you before, as I said, the proof is in the pudding, and we are able to tolerate 86%, okay? The fact that we're using out-of-band data protection means that we can really have or really leverage very narrow band IP connection. And if there is enough bitrate, then we can recover all lost packets in the receiver and maintain the timing. Now, unfortunately, in our world, there are no free meals. So the cost or what we have to pay is with additional end-to-end delay, typically up to 500 milliseconds. That would cover, I would say, the Euro vicinity, United States, Asia, etc. So now, with this power in hand, you could actually select a new operational working point. The first one is to increase resiliency. If the link budget allocated for a specific link is no longer sufficient, with video flow, the resiliency will increase within the same link budget. Another option is to increase the bit rate and still use the same link budget. So both options are the same, the same thing actually, and it only depends on which direction you would like to take this. And what happens if there is a complete loss, or the you know, the link is down or literally down? Then all of the packets will be transmitted by the terrestrial network. Now comes in mind the question, what happens if I don't have enough bitrate available to me in the terrestrial network? Okay, there is an answer to that. VideoFlow had developed adaptation technologies that can actually adapt the video rate to the link capacity. That we maintain the service availability, you know, at the cost of lowering the quality. But guess what? I didn't hear of anyone zapping to another TV channel just because the quality had degraded. But I did see many zapping to another channel if they see black screen or the picture is freeze. And at the moment this happens, the ad dollars or the ad revenue is plummeting. And this is exactly what we want to avoid here. Okay, if you have enough bitrate on the IP network, then it would smoothly move from the satellite link into the terrestrial network, IP terrestrial network, hitless. There would be no quality of experience degradation, meaning that you will not see any interruption to the video quality. So to summarize, video data transmission is sensitive because everything that happens to the data, either integrity or timing, is automatically shows itself into degradation to the video quality. We expect interferences to the satellite communication to grow over time. Video flow can offer a non-intrusive add-on products, meaning that you can use the same satellite system you have today, just add on the IP, the video flow, and then use any IP network of your choice. By the way, the cloud is also included. Okay, you can use AWS for distribution, you can use Google for distribution, you can use Microsoft Azure for distribution, or you can decide to have your own data center. All works. And as I said before, you could actually now select a new operational working point, either to lower link budget to maintain resiliency, especially you know, if you need to clear frequencies and you need to squeeze more frequencies into the same frequency band, or to increase the link bitrate using the same link budget. And that concludes my presentation. Thank you, Tony, and thank you everyone for listening.
Yes, thank you, Eran. Great presentation. I think we're hitting the Shannon limit, I suppose, for recovering all these lost packets and errors. Let me pick up a question which I have here from the screen. First of all, Haim Mazar is asking, how do you identify the origin of the interference? And also, second question, any monitoring of the received satellite signal?
Okay, two good questions. First of all, for the Haim's question, we don't actually identify the source of the interference. We identify the outcome of this interference, which results in a loss of data. And the moment there is a loss of data, we can come to the source and ask him and say, this portion of data was missing, and then retransmit it. This is the reason why we're adding additional 500 milliseconds on top of the satellite propagation delay to allow for this operation. With regards to the satellite statistics, no, because we do not actually have the modulator module embedded into our solution. The initial thinking was that there is already an IRD that is in place, so no need to replace this IRD, but we could provide a pipe for remote management. So if the IRD could provide the link statistic, the satellite link statistics, we can relay this statistic to the NOC, to the Network Operations Center.
Okay, another question. So your technology today is used for broadcasting. What about normal telecommunications? Is there any useful application to normal telecom, bidirectional telecom, or not?
Yes. At the end of the day, we had resolved the problem for, I would say, the most stringent type of application or data flow that is running in telecom network, which is video. The only thing that needs to be done is to adapt or to compensate for different types of protocols. And this is something we're definitely into it, and we hope to introduce new products in this area as well.
Thank you. Can I ask the panelists not to answer the questions, please? Because I need the questions for the end. I see that Vipin is answering all the questions now. We have no questions to answer for you later, Vipin. Thank you. Please don't answer the questions. Thank you.
Yes, I will.
Okay, I'd like to get Betty on the video now to make her presentation, please. Thank you. Your microphone, Betty.
Good afternoon, everyone. Can you see my screen now?
Yes.
So thank you very much. And a bit as a follow-up of this day that talks about applications, I want to take you on a journey of European Space Agency study that AB5 conducted a couple of years ago. A couple of years ago, I mean, actually, the European Space Agency has regular calls for business applications some calls are very, very specific, so some are more generic. And a few years ago, as AB5 was already working with non-geo satellite system, we decided to answer a call that was dedicated for what ESA used to call the mega constellations as enablers for new services and applications opportunities. The idea was to look at how these constellations could bring some added value, not only in bridging the digital divide and connecting those who unfortunately still have no access to internet, but actually go one step further and provide some applications that would be useful. This application could sometimes be transmitted by other means, but the use of the satellite technology, and we will see that in some instances, there were questions about the benefits between non-geo and geo satellites. There were questions about, of course, one of the key elements is the cost. So as we looked at that study, we first developed Answer the Call. So there was a competitive call for the European Space Agency, and we won that competition. So it was a great pride in itself. And we were able to start developing a first concept of what would be the criteria that we could use to select the applications and services. So as you can see, we looked at it in a broad manner, and we wanted really to serve the users. So the applications and services that we looked at didn't necessarily have technical issues, as long as they had a technical gap that was a new system that would be developed. But we tried to look at all these criteria that put together would have some weight and would allow to pre-select a certain number of applications and services. So a lot of work was done, and of course, the provision of the internet connectivity, it happens to be one of the most important topics, but this is a generic element of service that we didn't want to do. We wanted to go one step further. So with that in mind, we actually down selected 6 applications, and some had a bit of an overlap, while some were very specific and different. So one was about how to bring the e-government towards those in remote area, especially in Africa. The call included a request for some capacity building in Africa. We thought that was a good match. So we looked at a series of opportunities that could arise from the connectivity that could be deployed by the new satellite constellations into the remote locations that are currently not connected in Africa. One of the other elements that we looked at was about train and tram transport. At the moment, it's something that is big. I saw that there are plenty of calls that are connecting, about connecting trains. But 2 years ago, it was not a topic that was necessarily as high on the agenda as it is now. And what we looked at is about the connectivity, not necessarily from a safety point of view, but again, with a view of bringing some applications and services for the users. And what we thought about in that particular case, and I'm going to go and dive into some of the conclusions which reached, was to look at the actual integration between what satellite can bring towards the 5G network. What we realized is that in the train network, when you are in the UK and you are in a situation where a train is approaching London, you probably have a localization of that train which is within a few meters. However, when you are in Scotland, the way the train is currently located means that probably with your mobile phone, you have a better positioning than the train itself. It's in between 20 kilometers. So there are plenty of things that show that the train system actually would benefit from some new services and technology. What we looked at was more the applications that could be useful to the passengers. What would actually be useful for a train passenger, for a tram passenger, that would be enabled by the availability of new connectivity, especially those that would be brought by the satellite systems, such as the low Earth orbit constellations. Another element that we looked at was about the weather stations. It is really important in the view of climate change to look at how we can bring more information. I'm quite happy that we were one of the first to think about maybe implementing more connectivity for weather stations, and trying to make that a model that is available more broadly. The World Meteorological Organization has a number of registered weather stations in Switzerland, which equates the number of weather stations installed in the whole of Africa. So really, in order to improve that local weather forecast, the idea of connecting more regularly the local weather stations that could not be accessed by the mobile network was an opportunity. Related to that, in the weather management and with a view of climate change, there was a suggestion that actually the large satellite constellations, with a view of the user terminals, but that can be applied to some of the geo systems actually, being quite transportable now, there was an opportunity to maybe use that technology in an autonomous way, and address the disaster risks. And of course, disaster risk is now a topic that is quite broadly addressed, but what we looked at is an area which is less addressed than others, which is actually the disaster risk that happens, the alert that happen as soon as the disaster has stricken. So what happens when the disaster has been devastating a piece of land, or is about to devastate a piece of land, and let's say you are on the seaside, but you can go into a hill, but at the top of the hill there is a volcano, or you can go on the seaside. Which route should you take? What would be the best advice to save as many lives as possible? So that was a lot of effort into trying to see how to communicate to people, how to make sure the information is reliable, what can be done for that to happen. I'm going to go a bit in details on how we work, but of course you can see already that between the e-government applications in Africa, between disaster risk management, between the weather station, you already quite have some potential interaction and interfaces. One of the other studies that we looked at that would be a good match for the LEO constellations is about the mapping of the Arctic. Because of the current climate change, there is a melting of the icebergs, and therefore the northern route is becoming more and more open. Because of that northern passage being more open, there is more traffic and therefore more ships going there, both for commercial purposes and also for leisure. Because of that, and the fact that currently only 30% of the Arctic is actually mapped, there is a huge risk for these transports to happen there. So how can we improve the mapping, and how could the large satellite constellation support that mapping to develop it further and to ensure that the transport is safe? So one of the aspects we looked at was about using the low Earth orbit to improve the GPS positioning, because the GPS positioning at a higher latitude requires some triangulation, which is not necessarily easy to achieve. And in the end, we thought that one of the best elements in which we wanted to focus on was more on the mapping of the seabed and the melting ice by using a combination of devices on board ships and on board buoyancies, and looking at how we can develop a system like this that would be useful for that mapping and transfer the right data rate of data. This, of course, creates a few interesting developments, such as looking at long life batteries and also looking at electronics that are actually hardened and resistant for the winterization of the components, as well as the proximity of the water and humidity. Another element we looked at, where the geosystem is already in place and quite strong, but you also have the IoT satellite systems that are working on that, is the end-to-end tracking of containers and some specific materials. So one of the questions that we raised was, is the container, when you want to go end-to-end, you usually have a mix of transports that happen during your route or on your journey. So how can you make sure that that container, or probably what is inside your container, is actually tracked? And what happens? Do you track the ship when it's on board the ship, or do you track the container itself? How can you control some elements inside? What kind of goods and markets would be interested? So one of the key elements of this study was actually to really look at the user needs. So not only look at solutions that can be brought from a technical point of view, but really what would be the user needs that would justify the approach. For that, we created a specific team that had an interesting experience. In addition to me as project leader, I had a deputy project manager that was also an expert in weather systems, Yvette, and Gabriela works for AB5 on projects. So we were the backup project team, and we had a team of specific experts. Out of the 5 people in the team, only one really had some experience with satellite. Howard, who used to work for Inmarsat, was working on the operations of Inmarsat. Van Kai is a specialist of circular economy, 5G and transport. Veronique is a specialist of crisis management, dangerous goods transport, and end-to-end transport. Ren is a specialist of capacity building in Africa and the ICT development in Africa. And then Guillaume is a specialist of apps and technology. So what was also interesting is to bring all these many profiles, most of them not related to the satellite sector, and challenge them. And it was very interesting during the discussions, because the teams were mixed in order to answer the 6 applications that we decided to work on, was to see their approach as they had their expertise in their field, and see how this could be matched by the satellite systems and the new constellations. So of course, as you would expect, we did a lot of work based on either traditional or less traditional models. So we used the SWOT analysis, a pastoral analysis. We did a lot of interviews, we did surveys. We really looked at the technical gap. But one of the key elements we looked at was that importance of a sustainable business model that would allow a solution to be long-lasting and living. So after that, we developed a roadmap and a strategy for some, where we got into a deeper phase for some of the applications. We really tried to look at how these applications could be sustainable and developed, and where the satellite would bring some assets and value. For that, we spend a lot of time talking to a large number of stakeholders, and the dots are not representative of one person, but actually the capital of the country which we interviewed. As you can see, we were capable of bringing back a feedback on the user needs for all these applications throughout a large range of countries and a large range of applications. So it was quite interesting to see this mix of views and what people had to think about when we were proposing the solutions. So we involved the users, got their input, contacted them, got a lot of responses, went to conferences, explained, discussed, and actually I'm going to talk on the 20th of July for ACCESS.SPACE Alliance at the World Symposium of Information Society as a high-level track speaker about the digital divide. So it's a long-lasting relationship with WISES and the ITU that we have here, but it's looking at all these aspects and get a good sample of feedback. What did we find? We find that, of course, the importance is to define the market addressed precisely. So when we talk about e-government, what exactly do we want to achieve? And for instance, one of the ideas we had was to look more specifically at the registration of birth, not necessarily on the changing the traditional way of registering the children, but realizing that in some countries, and I was given the figure that 8 LDC countries in Africa have over 25% of the children birth which are not registered, and they are not registered for very good reasons, because the parents that unfortunately have to register the children would have to walk 1 week before they can access a service for that registration. And 1 week to go, 1 week to go back when you have a new baby is a challenge. So how can we bring some technology that would ensure that that data is preserved? I was discussing with a friend from India, and you would have the same situation about the registration, for instance, of the COVID death. She was mentioning to me that that was the challenge. And therefore, you really have the opportunity there to manage your population from a governmental perspective in a most efficient way, and try to save their lives and preserve and maybe also provide some services. We found that, of course, one of the key elements of satellite is the coverage of the remote zone. That, of course, when you look at developing an application, the graphic interface is the key element, and looking at a variety of solutions. You want to match the service with the level, service levels with the needs. What are the actual needs? Not necessarily the demand, because of course everybody wants to have a Facebook account, but is it a need or is it a demand? So try to look at what is the best trade-off, have that strong business case. We looked at the issue, and that came up out of the discussions between the experts about the data protection across borders, especially when we talk about security, government, even some national data, such as weather data. How do you manage that cross-border of data transfer? The level of identification of what you're looking at. One key element that was discussed here is the cost. And of course, coverage and local acceptance are very key. What you don't see here, which is interesting, is that most of the applications didn't require low latency. And that was intentional. The idea was not to serve a few sectors that maybe could be high value sectors, but really looking at serving more the geographies than actually some specific technologies. 1 minute left. Oh, so that was to wrap up on the various applications. But I want to carry on that story of that study because one of them is the interesting part of the weather monitoring and forecasting. When you look at the weather monitoring and forecasting, the question is that can you really deploy a sustainable network of weather stations in Africa? You need to maintain it. Is it worth it financially? How can this happen? So by the way of working through that, we, after this study, the ESA study concluded, so completely on AB5 R&D funds, we looked at the local weather is of good use to the farmers. How can we improve that? And as we dug up in the past 2 years, we've carried out a lot of studies about the purposes and the development of a platform that would be beneficial for the agriculture in Africa. So with that, I can only encourage you to go further. We actually have been able to assemble a project, and through funding by Innovate UK, we're going to start deploying a technology which is going to help some farmers. We're going to install a technology based on satellite, but with some IoT devices combined with connectivity to the farmers in broadband. And we're going to deploy that for the production of 21 cassava farms in Nigeria that will start with the planting this summer. We're hoping then to be able to commercialize the solution by spring next year. And at the same time, we're also looking at deploying the same structure for different purpose in Sicily in order to manage water in a more efficient way. So as in conclusion, you have seen that there are plenty of opportunities for satellite applications of services, but they need to make sense. They need to make sense financially. We've got a lot of experience in ESA studies and grant funding, and it is a great way to kick off a project, especially when nothing is starting and there is nothing at hand to really sustain a business case on your own, especially if you are a small structure. But the story continues, and I think it's a praise to ESA and its funding that we've been able to carry out from an idea and concept that stemmed from the ESA study into something that is becoming bigger and is showing the benefits of satellite in a better light. Thank you very much, and I'm happy to answer questions. Thank you.
Sorry, thank you, Betty. Can you, yeah. I'll ask you one question, then we'll start the panel, the Q&A panel, okay? Let's see, a question from Bijay Kumar Roy. What could other satellite applications in addition to telecom broadband and broadcast to increase the usefulness of satellite? What other applications are there in addition to telecom and broadcast, which could increase the usefulness of the satellite?
So it's true that the session here is focused on satellite broadcast and broadband, but you have the IoT systems, which we have to present here. I'm actually working with a new satellite IoT constellations, and they bring in VHF, UHF bands opportunity to connect small devices on the ground. I think it's a renewal of that technology that was developed 20 years ago. There is also the Earth observation sector that is providing a lot of opportunities for applications and services. And after that, you have a broad range of scientific uses of the satellites. It starts with measuring the height of the waves to some more specific elements that then have spin-off activities that can be commercialized.
Okay, can I have also Eran on the screen, so we all, the four of us are on the screen, all the panelists, please. Thank you. Kai Pang Tan, can you speak and maybe ask a question? I'm going to allow you to speak now. Can you try your microphone?
Hello?
Yeah, go ahead, Kaipan. You have a question, right?
Yeah, my question is to Patty. Thank you so much for your very inspiring presentation on the application of satellite, and weather monitoring, disaster response, and all that is also very much we are interested. My question here is, my company is not established in any of the EU region. So are we qualified to be in the ACCESS programs for that matter?
That's actually a very good question. It really depends on the call. There are some projects that actually refer to outreach we go beyond Europe, but most of the funding is based on geographic return. So some of the calls, and the call that I answered is not identified as a country return, but most of them would require you to have a base in that country and the work to be carried out in that country. And that would also require the need for a letter of support for that to happen. However, another way of working is that depending on what kind of activity you have, is having a partnership with a company in that country and develop something where it is a win-win situation. So on one side, you bring maybe your technology, but on the other side, there is an opportunity for the funding, and that transfers into a market which you know better than anyone else. So it is a potential for developing it that way.
Thank you. Thank you, I think.
And Kapang, you also have a question for Eran, right? Eran.
Yeah, okay. I think I am trying to understand Eran, the videos flow, technology. That is very interesting. But from your plot diagram, it seems to me that you do need to have the thresholds IP network to complement that. Am I right?
Well, you have to have a complement network, not necessarily terrestrial. It could be any packet-based network. It could be 5G, 4G, Wi-Fi, microwave, VSAT, you name it.
Okay.
Okay. The idea being is, I mean, we can also be on the same satellite link. Let me give you an example. Okay. Compagnie de Ponant it has some cruise ships that are traveling around the world. Okay. And they are visiting some at least visited some very interesting places like the North Pole, Tasmania, Iceland, etc. Okay. And you know what happens, to satellite signal when you are above 60 degrees latitude, right? So the thing is that they try to do many things, trying to have several protocols that they use today for, let's call it, for over the top, like like HLS and what you see in your website, and it simply didn't work. The good thing about VSAT is that not only it is a packet-based satellite network, it's also bidirectional. And the good thing about the video flow is that I really don't need a big chunk of a return channel, because at the end of the day, you could expect relatively low data loss in the downlink channel, in the satellite downlink channel. So the return channel is not going to be necessarily a big chunk of data that is coming back. So
I think yeah, understand. Thank you very much.
A pleasure.
Give me a lot of understanding. Thank you.
Pleasure.
All right, thank you, Kaipan. Pierpaolo Gigino, if you can unmute and maybe ask a questions.
Yeah, can you hear me?
Yes, of course.
Okay, I have two questions for Vipin and one for Eran, although half of it has been already answered, I think. Vipin is, I just wanted the technical side, is what is the ratio of the people served by each Wi-Fi station on your network, effectively the local network, and at which bit rate? And then the second question is, why did you choose Wi-Fi over WiMAX for that application?
Your microphone, Vipin.
Yes. Should I answer? Okay. So Wi-Fi over WiMAX is easy decision. See, when the areas we are talking about is actually very, very cost-effective, cost-sensitive, and ease of installation, availability, manufacturing. All those considerations are very, very simple for Wi-Fi. Wi-Fi is something that you can configure, install, operate. Also, technologically, the Wi-Fi technology is evolving with 802.11ax coming in, 802.11ac already being there. Also ABGN, they suffice most of the needs that you have. Consequently, selection of the Wi-Fi was natural. And the second part of your question, if you can.
That was basically, what's the ratio, what's the bandwidth and the ratio of people served per each station? How many people?
Excellent. Thank you very much. I think that will allow me to answer question a little bit better for everybody.
Yeah.
See, 1:10 is the cost element that I targeted and achieved. Yeah. What it means is that for satellite phone in India, you have 26 rupees per minute, which is very high.
Very high.
Right. And if you accommodate 11 concurrent calls in the same by using the techniques of compression and also spatial codecs, then 11 calls can go on the same. And that becomes 2.6 rupees, which is like, few cents per minute for the voice call. Then comes the video monetization. Since you are using the video download only when you are not using that link for any other purpose, you are able to actually provide full blast movies locally in the edge computer. That edge computer takes care of some of these things. It may not be real-time interactive, true HDR kind of situation, but very good for education purposes, very good for community awareness purposes. So that's what was the thing. The typical bandwidth that we got was 4 Mbps downlink and uplink, and the voice required very little of it.
Yeah. Okay. Thank you very much. The question for Eran is, I think you maybe answered already that, but it's still related to what's the split of the bandwidth you have on the Earth, say, versus the satellite. And particularly, when you ask for the retransmission of the packet, presumably you only ask for the packet retransmission. And do you tend to use the network side, or you actually use the satellite more?
Well, we are using the network side, but we can also use the satellite if the satellite is packet based. The idea being
I know that. You said that before.
Yeah, exactly. So the idea being is to use the terrestrial network and not necessarily the satellite, because if we want to achieve some kind of redundancy and backup that would be completely hitless, then we want to play with both connections, okay? And we also need diversity. So one connection is going to be satellite, the other one any type of other connection, okay? Does this answer your question?
Yeah, more or less, yes. And I still have another one, which you basically are effectively caching all the data for 500 milliseconds longer in order to allow for the correction effectively. Am I right? Yes,
you're right. It's not necessarily, the 500 milliseconds is just a number. And thank you for the question. The idea being is that for retransmission, you have to take into consideration the round trip delay between the receiver that is asking for the transmitter to resend, okay? And we also have to take into consideration the fact that the IP network is not is going to lose some data as well. So our recommendation would be to have at least allow time for 5 tries like this. If, for instance, the delay between the transmitter and receiver is going to be, let's assume, a round trip delay of 40 milliseconds, then we can drop this number to 200 milliseconds. If, for instance, like we had a link from London to Sydney in Australia, where the propagation delay was about 250 milliseconds, then we had to allow for at least 1 second, to go. And once again, if it was not that clear at the moment, what we're focusing on is on professional video distribution and contribution, not necessarily to the set-top boxes. Although I think that the issues with C-band and 5G are going to incarnate themselves, into set-top boxes in a later stage.
Okay, thank you for that, Paolo and Eran and Vipin. Betty, there's a question for you. Anonymous attendee asking the following: do you know why ESA proposed a study to look into possible new services which should actually be already in the business plans of every constellation we hear about? And then it is a bit worrying if those proposing LEO constellation did not do this already without. Wouldn't you agree?
No, I wouldn't, because the studies were actually launched by ESA in 2016. So you have to remember that when OneWeb came up in 2015, it was one of the first ones to actually declare themselves as that new wave of non-GSO systems. And therefore, when ESA came, they were really looking at one step forward. So it was planning on what else could the connectivity bring. Because it's one thing saying, I bring connectivity to you, but to do what? What can you actually transform that into something which has a value added rather than just bringing that infrastructure to people? So it's a bit of the question that Haim is also asking on the chats about what technology do you choose, and Haim is perfectly right. The idea is not to have solution, everything is satellite based and should be satellite based. Things that to be based on an economic model that is worth it. But if I look at the cassava farm on which we're working, out of the cassava farm that we're going to install, the 21 farms, only one has irrigation, one has electricity, and none of them have connectivity more than 2G. So at the end of the day, there's still a big gap, and it's one of the southern states of Nigeria, which is meant to be a bit more driven by agriculture. So when you look at that, you realize that there's still a need to provide services, but it needs to be balanced. And I'm sure Vipin will find the same in India.
Yes, can I come in?
Of course.
Tony? All right, I think this is so exciting, the way discussion is going on right now, is that, there is a standard by ETSI called the standard name is 1M2M. 1M2M is a wonderful standard that has been built and accepted globally. ITU also has taken that as a reference architecture. And what it does is that it allows you to have an edge device to connect all these IoT devices. And the LoRa, for instance, which is a PAN protocol for connecting IoT, goes as far as 1.5 kilometers from a single place. And also Wi-Fi itself is very much usable for the IoT. Consequently, IoT becomes a natural use case once we put the kind of system that I talked about. So the IoT and the sensors, you don't have to go everywhere, right? You need to aggregate at one point where you are connecting to satellite and then put the identity stream of that. And you can connect, 10,000 sensors if they're not really video cameras.
Okay, I have Daniel Wiyogo. Could you please say who you are and you work for, and then you can ask a question, Daniel? You need to unmute, please. Okay, Daniel is not answering, so let's go with the next speaker. Hi Mazar, you have lots and lots of questions, but can you actually please, at the moment, ask one question at a time? Thank you.
Okay, I will be very brief. First of all, I like very much the presentation. And in parallel, I participate at IQR 5D. I serve as the vice chair of study group 5. My concern is I am a lot in Africa, a lot. And I saw that in $10, you get a cellular. And you get everything. The salary, you get it by cellular. So I think that the cellular killed the iridium. And now the question is why to use satellite communications if the cellular is so low in price for the equipment and for the use? Thank you.
Thank you, Haim.
As I said, it doesn't necessarily mean that you have to use the satellite everywhere or the cellular everywhere. What happens is that what kind of connectivity and data rate is your cellular $10 giving? Are we talking about hundreds of kilobits per second? Are we talking about megabits? What kind of data rate are you getting through that connectivity?
Okay, so next question. Go ahead. Sorry, Vipin. Go ahead, Vipin.
I think, we have to understand that we are serving communities. And we are serving the people who are cannot afford individual subscription debt times. We are talking about the education and to need to be provided. Consequently, having one satellite link and getting maximum juice out of it and connecting communities actually is the way for you to really propagate the satellite. Because you see, you put fiber everywhere, right? There are places where all around the island there is a fiber, but no connectivity inside. Why? Because laying fiber is so expensive, doesn't make sense. Whereas satellite is everywhere, you configure it in your headquarters, take it, put it there, the whole damn thing works in a minute. And the system is so simple. People have not understood the power of simplicity of satellite as of now. And people have not understood that laying the cables, long cables, or putting large radio links everywhere is damn expensive. It requires at least 100 subscribers for a particular BTS to become economically viable. So are you going to have that kind of a scenario? So comparing a single handset with the satellite connectivity is probably unfair.
Yeah, I agree with that, Vipin. Thank you so much. Eran, question for yourself now. Is the video flow, so since we're talking about LEOs and GEOs and satellites, is your solution for hybrid satellite IP applicable to LEOs and MEOs as well?
Yes, definitely. Any type of satellite. Our solution is for any type of application, including satellite. And if I may, to relate to the other question of Haim's question and Vipin's answer, sometimes in broadcast, the only way to have a decent video quality is by using satellite. It's not that you don't have the terrestrial connectivity or other means of connectivity. They are either expensive or insufficient or both. So this is the reason why the hybrid came into mind. It's not replacing satellite with IP networks. The idea being is to work together and to make it more accessible to other solutions, other locations, other applications that without it would not have happened.
Okay, excellent. Thank you. I have a question from BJ Kumar Roy from Nepal. BJ, would you be able to speak and ask your questions to the panel? Can you unmute your microphone? BJ? Okay, while BJ is trying to do your microphone, I'm going to ask the question.
Hi.
Oh, go ahead. Go ahead, BJ.
Thank you all the speakers, the panelists, for such a nice presentation. Actually, I was asking about this because we talked about different type of satellite services from LEO, MEO to GEO, and many times we hear the satellite operators or providers in Nepal, and they come here to offer services, and sometimes it is really difficult for us to choose like which one to go for, MEO or GEO, or so this I think the Betty has good experience on these things, so I think this will be a good question for her.
Thank you very much. And actually, it does even more more value. At the moment, I'm helping a remote region of one country to get satellite connectivity via satellite. And they asked me the exact same question. Do you get a LEO, MEO, GEO? And my answer was quite simple. My answer was, look at the ground terminal, because what you're needing to do is what is the user gonna do? You want something which is easy to install, easy to maintain, with a reasonable cost of infrastructure. So when you buy your user terminal, which may then, as Vipin explained, serve a community with their own mobile phone and Wi-Fi, 4G, 3G, whatever connectivity you want to relay, or if you want to do it directly to home, as you can do in broadcast, but you can do that in broadband, you have to look at the cost. And it's that balancing out of the offers that will make a difference to you. The quality has also an impact, but as Eran explained, there are ways around them. Now, if there are operators on the call, satellite operators, what I'm really looking for is that eventually we reach out to the same level as the GSMA community and have better interoperability between the systems. So when you are somewhere, you don't need to think, should I have a LEO, a MEO, a GEO? Should I have that operator or that operator? But you have one terminal, and then you have an offer which is given to you, and you sort of destructure the infrastructure layers that you have in the mobile sector. So that's what I don't know. It came through the GSMA power to bring people together. I hope that that will happen to the satellite community to serve better the end users.
Vipin, you have anything to add?
Um,
And Eran as well?
Yes, I think, you know, I would agree with Betty. The important thing is the coverage and capacity. And whether it is LEO, MEO, GEO, what gives you a better bit error rate, what gives you a better bandwidth, and what gives you a reliability in during the TOD, time of the day of your operations, is the key consideration. The constellation of satellites, if they are interconnected with each other and trying to deliver you the services, then the continuity of services becomes very important. But in the end, like Betty very well explained, that we need to worry about how we are going to serve the community and what do we get out of these constellations.
Yeah. So my 2 cents on this is, first of all, I am totally in line with Betty and Vipin. At the end of the day, it is related to economics, and there is satellite economics. There are some applications and some, I would say, geolocations that satellite would most probably be the only way to go. Okay. Let me give you an example for this. Everybody is praising 5G as the new, way of conveying data, high-speed data to everywhere. Well, maybe, not everywhere, not at high speed, not now. And in order to get this 5G thing, really working, you have to tighten the grid to such a place where you would have to have a base station every half a kilometer or so. That's, and if you're talking about obviously the suburban rural area, forget about 5G. So all the big plans on having 5G everywhere is just not going to happen, in my opinion. Or if it's going to happen, maybe my grandsons will see this happen. Take Vipin, for instance, okay? He's talking about a 2G connection, okay? He's talking about, providing a simple, cellular connectivity. So he thinks of a satellite as an extension solution, a very cost-effective one, okay, that would actually increase the availability of a service to locations where only satellite can make the difference. So once again, economics, requirements, cost.
I have to agree and disagree with everyone. I think for countries like Nepal, for example, where they are in the mountains, and there's a lot of shadowing and blockage by mountains, LEO constellations likely are the best solutions because you can always find a satellite always above your head, unobstructed. While with GSO, for example, you have to point south to the equator. You may have a blockage of a mountain or blockage by a building or whatever. So it's difficult, most likely, to get a geo solutions. Of course, there are places where you can get geo, and of course, then you have to weigh between what is the end use, what is the use case. Basically, it's always about the use case at the end of the day. What is the end user going to do with the data? How much data is required, and the cost of the data. So it's a solution that needs to be studied, analyzed, and get the different options together, in effect. So that I totally agree. For 5G, I also agree with Eran on the point that most likely 5G will be a solution which is highly going to be used in cities, whereby the backhaul to the base station is available all the time. And in rural areas, 5G can only be used most likely using satellite backhauling. And of course, at that point, then you would have to get technology that would have the lowest latency. I guess, again, LEO and MEO could be the solution. MEO may go up to 110, 150 milliseconds, the lowest minimum latency. With LEO, you can go as low as maybe 10, 20 milliseconds, depending on the constellation height. So 5G is going to be there, but not everywhere, most likely. And in rural areas, most likely LEOs and MEOs will be the solution to backhaul it, basically. Any last words from the panelists? Please, this is the time before we close.
Yes. I think we have to be aware that the recent changes which are happening is allowing the high altitude satellite platforms to be coming along. And I know these are like hanging in the sky somewhere, consolidating all the satellite data because it's coming from the sky and then bombing it down to the ground and still trying to make money. So that's why it is important for us to look at the new changes which are now coming in the radio regulations and allowing us to have a good time of the IP connectivity as we go forward. Having said that, the one very good question came about from somebody about the synchronization of the time. And I just want to put across that nowadays the synchronization is we are able to have up to 1 nanosecond, like it will be used for 5G. And in the satellite kind of a thing, 1488, version 2 is good enough for us to synchronize all the things that we are doing so that we are on the same page.
Thank you, Vipin. Betty, Eran, anything else from your side?
Yeah, I would like to thank the other panelists and you for organizing the session. It was very instructive, and I really enjoyed the activeness of the questions by the participants. So thank you to all, and I think you can bring something back. There are plenty of opportunity to develop your apps, and it doesn't necessarily cost a lot. So think about it wherever you are, and create value around you, and happy to carry on. If people are interested with our new venture of the Farmer Charlie, please contact me in trying to bring that connectivity to the farmers.
And also for any ESA projects bidding, Betty's the expert. Eran, any last words?
Well, thank you very much. It was very exciting, to hear all of these questions. I think that I was wondering if the three panelists will have the same line of thought. I think we were like 90% there, in line with what we think, which was great because nobody can blame that we had the opportunity, to match what we're going to say. And thank you very much for everybody for joining, for asking, and for you, Tony, to arrange this great webinar.
So before we leave, I just want to say a couple of things. Before we, even before that, could every panelist come together on the screen so we could take a photo, a screenshot, smile, Ready? Now, okay. Now my last bit. I'm going to share my screen with everyone. Just a second. Let me go to the right page. Last page. I want to thank VideoFlow for sponsoring the webinar today. We had 3 great presentations from Betty, Vipin, and Eran. Thank you very much for today's presentation. I wish you good luck with your work and with everything. And this is our screenshot from about 10 minutes ago. Thank you. You will receive this and also the screenshot we just took. And also, I want to remind everyone that tomorrow we have another webinar on the key technologies for high power space missions. That is how you get to the moon, for example, to Mars from low Earth orbit using high power transmissions, high power missions, basically, which may use also high conductors, basically, and high power systems to basically move a lot of mass from low Earth orbit to the moon or and beyond. Next week will be a lot going on about orbit servicing, propulsion, and situational awareness. Stand by. I will send you the invitations. And in 2 weeks' time, we're going to have an ITU panel. I am done. Thank you so much for everyone to have come to this panel. I hope to see you soon. Take care, everyone.
I want all the panel members to maybe say this, right? If you enjoyed, thank you.
Take care. Bye-bye.
Take care. Cheers.
Bye.